Hi guys, this is Sai Rahul. I am presenting you a new video. This is a part of our ATT Tech Talks May 2020. Today I am going to discuss about drive system efficiency in all type of motor. We are not going to stick to particular motor. We are going to touch the common part of all the motors drive system efficiency. Let's get into the content. Here comes our first content. Like we are going to introduce about this about the system, driving system, etc. And we are going to explain you about the advantages of driving systems and different types of driving systems that we are using, and drive system efficiency, which is a key part of the this video, and power stages in motors and their efficiency, and the types of motor efficiency, which is very important to learn to get some experience in the industrial level. And finally we are going to how to improve the drive system efficiency, and let's get into the conclusion. That's what we are going to see in this video. Now without any lag, let's get into the video. Yeah, here comes the introduction. In many electrical motors are using 65% of industry energy. Most of the in many industries we are seeing many big machineries. To run a particular machinery, there must be a motor to run it. And motors are the main part of many hardware industries. So it is very important, not only in hardware. For example, if you take any electronic industry, like you have let's take a mobile manufacturing company, there going to be a conveyor belt where they are going to use a big size motor. So 65% of the industrial energy is consuming by the motors itself. So there is a need to increase its efficiency and decrease its energy losses. This is why we are taking a main focus on driving system and efficiency of the motor, so that we can gain some sustainability or some efficiency of the motor. Yeah. Here are the advantages of electrical drive systems. Why we are learning this? It is simple to construct and maintenance cost, which means if we are increasing the efficiency of the motor, automatically we are decreasing the maintenance cost. It's easy, and we are making it easy and smooth. Like you know what, we are there are small convenience, like we can be remotely controllable and compact, and it requires less space, and it longer life, because it will have longer life because we are maintaining it at a particular level, that so that we get more efficiency, right? These are the few advantages of electrical drive systems. And here comes the different types of industrial electric drives, like different types of motors. Simply we can say these are different type of motors: DC shunt motor, DC series motor, compound motor, three-phase synchronous motor, squirrel cage induction motor, double squirrel cage motor, slip ring induction motor, single phase synchronous motor, single phase series motor, repulsive motor, capacitor start induction motor, and capacitor start and run motor. There are nearly 12 different types of motors which you are using in present day industries. And here comes our main theme: motor drive system efficiency. As I mentioned, already mentioned that efficiency is a key part in every motor, because to do a particular phenomenal job, the motor should have at its maximum capacity. See, electrical motor is a type of machine which converts electrical energy into a mechanical energy using the interaction between magnetic field and current in its winding to generate the force in the motor. I think you have already seen on few how the motor works and how the generator works. So I was not explaining all the things. Electromagnetic is the main phenomena that is used by the motors, and the ratio between motor output and input is called efficiency. To calculate the efficiency, we are just going to measure how accurate we are getting. Like, see, for example, if you are using a particular application, like for not particular, but you can see, like, uh, you are suppose you are going to for a rice mill. You are going for a rice mill. You are giving full grains, like whole grains, without any filtration. They are going to get it from directly from the farms, and they are going to filter, like they want. They're going to do some processing. Before processing, we'll calculate how much rice is there, and after filtering, processing, we are going to check how much. Definitely there going to be a difference. This difference is known as the efficiency. So the ratio between the output and by input is called efficiency. We can check efficiency in all the things, like we can check the efficiency in the wires, we can check the efficiency in particular applications, etc. That's just whatever thing we are dealing with efficiency, output by input. That's the blind rule which we have to follow. For motor efficiency, simple, the motor efficiency formula is motor output power by motor input power. That's what the efficiency. Simple. Here are the few efficiency. Here are the few efficiency system drives. Like you can see, motor efficiency is denoted by ETAN. It's like efficiency symbol is N. Output by input into this is the percent. First one is the percentage, and the second one is second and third formulas are given when we have given few losses or input. Like, see, if sometimes we will get like for example, in rice mill, the when we given the whole grains, after removing the first mode layer, the first mode layer is a loss of the process. So they might given that about the details about first layer and the whole grains. They may ask us to find the complete output, so we must make sure that we have to know whether they have given the loss or input or output. This is the most important. With the help of it, we can change the formulas as per a requirement. So here are the few formulas to find the efficiency of this system drives, and here is the power stages in motors and their efficiencies. Like, losses occur during the conversion of electrical energy into mechanical energy in electrical motor. Not only in electrical motor, in every system, when there is a conversion from one energy to another energy, there are going to be losses. For example, if you are going to take the conversion like potential into kinetic energy, definitely there is going to be some loss. And other, for example, if you are going to use thermal energy to light energy, or this will be definitely going changes. Like in resistor, the electrical losses of electrical energy is converted into thermal energy. So even the losses will be in a particular energy form. So it will be helpful for us to understand the diversity not of the system. And now we are providing input power to the DC motor in the form of watts. Then copper losses occurs in armature winding and field winding. Now put power, copper losses in equal to the driving power. I just want to know. I just want you to know how the losses will occur, because sometimes we have to find the losses and later we have to check the efficiency. So to maintain some to maintain the relation between this one, we have to make sure that what variables stand for what. So we have to know what is what. So in this slide you can learn the formulas of the losses, so it helps you to get a particular efficiency of the motor. And here are the different types of efficiency: mechanical efficiencies, electrical efficiencies, overall commercial efficiency. You can see as in the film, like no sorry, as in the peak, you can see motor input in watts, where from A to B there is a particular losses which is called copper losses. Copper losses is nothing but it's like in wires we use copper loss. And second chamber is B, drive power armature watts. And third, from B to C there will be some losses like friction, iron losses. These losses are common in all the systems. And third is output. If you want to check the efficiency of the, you have to check simply C by A, which shows the efficiency of entire system. If you want to check the electrical efficiency, you have to check first B by C, because in this you can all see there will be only copper losses. Like there is from, you know, motor is nothing but conversion of electrical to mechanical, but it directly won't transfer from electrical to mechanical. There will be some different, like they're going to be mediator. The mediator is nothing but B, the chamber B, driving force in armature is the mediator. A and B belongs to electrical and B and C belongs to mechanical. So if you want to find the mechanical efficiency, you have to go with C by A B. If you want to find the electrical efficiency, you have to go with B by A. And if you want to know the overall efficiency, it's very simple, you have to go with C by A. As I already mentioned, output by input, it's just simple. And here is about very few information about energy loss, because energy losses is very key in to increase the electricity like efficiency, like not electricity efficiency, to increase the drive system efficiency of motors. Because without knowing the losses, we can't calculate the efficiency of the motors. So here is the formula for energy losses. These ohm, Eh, these all are particular losses. See, for example, ohmic losses, which comes from the resistors, and here comes eddy current losses, hysteresis losses, the rotating mechanical losses. These are the losses which will have in all motors. So we have to make sure that these losses should be very less. There will be no motor having without having these losses. So we have to make sure that but these losses should be less. This is the most important criteria which we have to see to increase the efficiency of a particular motor. And here comes our final methods, how to improve the drive system efficiency. This efficiency of motors is affected by few losses, as I already mentioned. So we have to take care about this. There are some small technical, like you know, there is a small hardware work, like functionality of frames of motor is to be provided mechanical protection to the winding. It is also responsible for the interface for installation through feet. The motor frames plays critical role in the thermal process because it is responsible for transfer the heat generated inside the motor. So we need to keep a fan, so it reduces the heat losses. Another basic tip is to keep minimum gap between any walls position in the back of the fan, because to get cooled we need some space. For example, if we overuse the particular drive system, like if you use the particular motor more and more, then automatically the system will increase its heat. There will be loss in heat. So we have to make sure that there will be no loss in heat. And third thing is the major component of a motor is stator. There will be 60% of losses in the stator part. So we need to reduce these losses with much care. And there will be motors that are highly efficient contains 25% extra copper as compared to motors that are designed for standard efficiency models. Rotor losses are also considered as a secondary source of losses that are largely caused by the degree slip displayed by motor. Slip is actually difference in the rpm, like it's after difference of speed and the magnitude and the actual rpm of motor and shaft at a given load. Copper must be largely used because copper has high conductivity, but copper must be die cast as a recently process have developed for die casting of copper. This is a new system which has came into the market, and to reduce the efforts of hysteresis and saturation steel containing small amount of silicon to be used in lamination instead of low cost carbon steel. In this way, core losses can be removed by reducing the thickness of lamination and increasing the length of the lamination that can minimize the flux density and core loss. Eddy current losses can be largely minimized by ensuring proper insulation between the sheets and the lamination used. And the final thing is we have to use a particular lubricant so that there will be no friction and there will be no heat production when the motor goes up. And here are the strategies to increase the motor drive efficiencies. uh, the first thing we have to simply follow three steps. First is assessment. We have to assess the motor, like how it is working, how we, and like we are just going to watch the characteristics and properties of the motor, like you're just observing a person. It's like simply you can compare this assessment, like you these three steps with an assessment of uh, person. Like see how we assess the person, his character is like this, his character is like this. We have to assess the motor first, and second we have to improve the losses, like sorry, we have to avoid these losses to improve the efficiency. So we can do this one only by assessing the particular motor. Without assessment we can't do it. So first we have to do a proper assessment of the motor, and later we have to improve the effectiveness or efficiency of the motor, and we have to make it prolong for life period. Like if you increase the service of the motors, then automatically life prolongs. If the product is doing good, automatically life will prolong. So like with the best example, if you maintain your body perfectly, like eating healthy foods, healthy diets, automatically your life will be boosted. Similar with the first step will be continuously monitor and document which motors are present under supervision, and we have to know how what kind of efficiency we have to calculate, and we have to make sure that we are checking it daily and daily. So these are the main, these are the main key solutions and issues of driving system efficiency in all type of motors. We explained how to increase the drive system efficiency in all motors, not only in particular in all motors. And we also explained you about different types of motor which we have. So there will be no change, but there will be only change in different types of circuits, but there will be no change in motors. So these are the basic things which every motor should have. So I hope you understand the content very well, and thank you for watching our video. Thanks.